Hello, my name is Edwin Lotter. I'm CEO of LP-Montagetechnik, a German company which plans, develops and implements manual and semi-automated assembly workstations, respectively assembly lines, such as one-piece flow systems and so on. In my previous video, I explained some basic information about MTM in general, its origin, and the main benefits in using this method. In this video, I show an example of real application of an MTM UAS analysis which was performed during the process mapping of a PCB assembly in our Trinity use case demonstrator. This analysis was important for the planned allocation of work between human and robot, with the aim to avoid waiting time for the human in determining the time available for the robot. The images on this slide give a rough overview of the current situation of manual work about manually assembling the circuit board with various components. For the subsequent distribution of the various assembly steps between humans and robots, it is important to determine the time analysis of the individual assembly steps within the total effort. As in my first video already explained, there are several options to carry out a MTM analysis. For example, MTM time block table, a sheet of paper, a pencil, and a pocket calculator are enough. Or computer-aided procedures like TICON 4, which is available at the MTM Association, or MTM UAS calculation sheet, including primary and secondary analysis developed by my company LP-Montagetechnik based on an Excel calculation sheet. For the MTM analysis of our demonstrator, we used our own developed calculation sheet, which I would like to explain using the selected analysis example. Here you can see the empty calculation sheet for MTM UAS. But please note that using our MTM UAS calculation tool does not exempt from MTM education in a national MTM association. In the headline, fill in the company name, the task, respectively the analyzed product or variant of the product, and if necessary, annotation of quantity or batch sizes, etc. How to use our MTM UAS calculation sheet. The left column describes the components and the task steps. In the next column, enter the MTM UAS code, and the next column on the right side displays automatically the TMU value. In the next column, enter the frequency if it's more than 1, and the last column shows the total amount of this row. The two rightmost columns automatically calculate the split of the value from column 4 on the left into primary, that means value added, and secondary, non-value added effort. This works very well with smaller products. With larger products, with of course some larger components, it may be that one or another value has to be readjusted manually. The space between the 4 columns on the left and the 2 columns on the right can be used for additional comments. And finally, you can enter the number of circulated product in case you have a part carrier with several fixtures, such as, for example, is in a one set flow assembly system. In our exemplary use case, MTM UAS calculation, we started with the first steps: fetching a part carrier from a trolley, bringing it to the roller conveyor, picking up a circuit board including a visual control by using a magnifying glass, placing it on the part carrier and scan the PCB. Next, all the individual parts are then picked up one after the other from the supply bin and insert into the printed circuit board. Since the components are quite small and each part has to be placed 12 times, it is possible to grasp quantities with one hand. The actual placement then takes place from the quantity of the parts in the hand with the shortest possible distance. Remaining surplus parts are thrown back into the particular part bin. Finally, when all the parts have been assembled, another visual check is carried out and the circuit board is handed over to a loader. The two columns on the far right show the automated result of primary and secondary effort, which means the distinction between value-added effort in the terms of customer benefit, these are the primary ones, and secondary effort that does not bring any benefit. The challenge is to minimize the secondary effort as much as possible to increase the primary effort. The result is a statement about the efficiency of manual work system and finally crucial for the division of labor between humans and robots. If you have any questions about using our MTM UAS calculation tool, don't hesitate to contact us. Thank you very much for your interest.